Now we will study linear programming problems or LPP. Linear programming or LP is a mathematical technique for optimum allocation of limited resources such as labor, material, capital, energy and so on to several competing activities such as products, services, job, new apartments, project and so on the basis of a given criterion of optimality. Structure of LP model. The general structure of LP model consists of three components. First component is the activity or variables and their relationships. The activity values represent the extent to which each activity is performed, represented by x1, x2, x3, etc., xn. These activities are also known as decision variables because they are under the decision maker's control. All decision variables are continuous, controllable and non-negative. That is x1 greater than or equal to 0, x2 greater than or equal to 0, etc. xn greater than or equal to 0. The second component is the objective function. The objective function of LP problem is a mathematical representation of the objective in terms of a measurable quantity such as profit, cost, revenue, distance, etc., which is represented by optimize or maximize or minimize z equal to c1x1 plus c2x2 plus c3x3 plus etc. cnxn, where z is the measure of performance variable. C1, C2, etc. Cn are parameters or uncontrollable variables that give the contribution of a unit of respective variable x1, x2, etc. xn to the measure of performance of z. Third component is the constraints. There are always certain limitations on the use of limited resources. Example, labor, machine, raw material, space, money, etc. Such constraints must be expressed as linear equalities or inequalities in terms of decision variables. The solution of an LP model must satisfy these constraints. Assumptions of LP. First one is certainty. It is assumed that all the model parameters must be known. Second is, if they are random variables, then the given problem can be solved by stochastic LP model. Second assumption is divisibility or continuity. Solution values of the decision variables are assumed to have either whole numbers or mixed numbers. Third one is additivity. The value of the objective function for the given values of the decision variables and the total sum of resources used must be equal to the sum of the contribution earned from each decision variables and sum of the resources used by each decision variables respectively. Fourth assumption is linearity. All relationships in the LP model must be linear. General mathematical model or LP problem. The general LPP with n decision variables and m constraints can be stated in the following form. Optimize, that means maximize or minimize, is equal to c1x1 plus c2x2 plus c3x3 plus etc. plus cnxn subject to a11x1 plus a12x2 plus etc. plus a1nxn less than or equal to or sometimes equal to or greater than or equal to b1, a21x1 plus a22x2 plus etc. plus a2nxn less than sometimes equal or greater than or equal to b2, etc. an1x1 plus an2x2 plus etc. plus a n and xn less than or equal to greater than or equal to bn, where x1, x2, x3, etc. xn greater than or equal to 0. Here Cj's are coefficients of decision variables. Xj represent their per unit contribution to the value of the objective function, and Aij's are called the technological coefficients or simply coefficients, and they represent the amount of resources consumed per unit variable. And now Bj or Bi's represent the total availability of ith resource. Now we can see some important definitions of this module. First one is solution, the set of values of decision variables which satisfy constraints. Feasible solution is the set of values of decision variables which satisfy the constraints as well as non-negativity conditions. Third is infeasible solution, the set of values of decision variables which does not satisfy constraints as well as non-negativity conditions. Next is basic solution. For a set of m simultaneous equations in n variables, n must be greater than m. A solution obtained by setting n minus m variables equal to 0 and solving for remaining equation in m variables is called a basic solution. The n minus m variables whose value did not appear in the solution are called non-basic variables, and the remaining m variables are called basic variables. Basic feasible solution. A feasible solution to an LP which is also the basic solution is known as a basic feasible solution. Basic feasible solution are of two types, degenerate and non-degenerate. A degenerate means a basic feasible solution with the value of at least one basic variable is 0. Non-degenerate means a basic feasible solution with all m basic variables are non-zero and positive. Now optimum basic feasible solution. It is a basic feasible solution which optimizes the objective function. And unbounded solution. It is a solution which can increase or decrease the value of the objective function indefinitely.